Hello everyone, in this video we are just going to see in detail what are timers in a microcontroller and how they are useful in generating accurate time delays inside the microcontroller, especially in STM32F4 series microcontroller. Let's get started. So what are timers? Timers are peripheral inside a microcontroller which is useful for counting accurate time delays inside the microcontroller. It is a separate peripheral rather than inclusive inside the CPU of the microcontroller. So the important applications of timers are accurate time delay generations in your programs, measuring frequency of pulses in case you are measuring some RPM from a wheel, etc. You can use this timer module inside the microcontroller for measuring the frequency and for generating PWM signals. For example, if you want to control a brightness of an LED, you can just generate PWM signals for controlling them with the help of the same timer modules. And also they are useful for triggering external devices or peripherals. So timer is actually a counter which counts accurate time delays in the program. So it is like a clock ticking time. This is also a clock inside the microcontroller which is useful for counting time intervals between events. So there are two types of counting that is happening in the timer of a microcontroller. One is up counting, which counts from 0 to a pre-programmed value or 0 to a maximum timer load value, and another one is down counting, which will be counting from a pre-programmed or the maximum value till the value 0, which is the minimum value of timer. So in our STM32F4 series microcontroller or in STM32 series microcontroller, the counting operation that is performed inside the timer is of up counting. So let's take an example for understanding the process of timers in counting time. So I'm just going to fix the pre-programmed value to be 5. So I have fixed the pre-programmed value to be 5 in my microcontroller. So what the timer does is, as soon as it starts counting time, it starts from the value 0. As I said, this is a up counting process that is held in the timer of STM32F4 series microcontroller. So it will count from the minimum value 0. So it will count from 0 and it reaches 1, 2, 3, 4 and 5. So as soon as it reaches the pre-programmed value 5, what happens here is it will be clearing the timer counter value to 0, and after this it continues the same operation. It will be counting 1, 2, 3, 4, 5 and again it will fall down, and the process goes on like this again and again. This fall happens to 0 and the process continues. So based on the timer counter value, manually you can program the microcontroller to achieve accurate time delays. By checking the preloaded counter value of the timer, we can just produce accurate time delays in the program. And also there is another method called update timer event method, that is the update timer interrupt method. So whenever this fall of timer happens from the preloaded value to the initial value, you can just trigger an interrupt to the processor using NVIC called timer interrupt. So using that interrupt, you can just write down your application as per the application needs. So using this also you can produce the accurate time delays in your program. That is, the timer interrupt is also useful for producing accurate time delays. Or what you can do is you can just manually monitor the counter value of timer, that is 0, 1, 2, 3, 4, 5 in this case, and you can clear the timer value based on the application needs. That is, for example, if you want to produce 5 millisecond delay in your program, you can just configure the timer for 1 millisecond step each, and you can just wait till the count value reaches 5 and you can clear the process. If you want 4 millisecond time delay, you can just wait till the counter value reaches 4 and you can clear the timer counter value. So this is a manual method, but the automated method is like waiting until the update event or timer interrupt occurs right over here. The time gap between each step, for example, you can see on the screen the time gap between the step 2 and 3 or 1 and 2 or 3 and 4 is the 1 tick of timer. As we say, our clock will tick for every 1 second. This particular time gap between each step of the timer is called 1 tick of the timer. So we can configure this particular speed of the timer by using several factor called prescaler, etc., that we will see later in this same video. But as soon as you configure the timer, each step of the timer will be having a time gap. So based on that time gap, you will be able to program the timer for producing accurate time delays. So for further clarity, you can just refer the user manual of the STM32F446RE microcontroller for further details, or whatever the microcontroller that you are working on, you just want to look into the reference manual or user manual for availability of timers in your microcontroller. So as per the STM32F4 series microcontroller, we have timer 6 and timer 7 to be basic timer. These details I have just derived from the reference manual of the microcontroller. So basic timer means this particular timer is useful only for producing accurate time delays or accurate time delays at every timer interrupt that is occurring. And timer 2 to 5 and timer 9 to 14 are general purpose timers. So these kinds of timers are most widely useful for producing accurate time delays and also for generating PWM signals, etc. So these timer 2 to 5 are 32-bit timers. So it will be varying the counter value from 0 to 2 to the power 32. And these timers from timer 9 to 14 are 16-bit timers. So timer value of these timer 9 to 14 will be varying from 0 to 65535, which is 2 power 16. And the timer 1 and 8 are advanced timers. So these are most widely capable of performing every single operation that is available in timer. That is, they can be useful for producing accurate time delays, and also they can be useful for producing accurate pulses, that is PWM pulses of required period and duty cycle, and also they will be useful for reading the pulses in the timer input capture pin. So on the screen now you can see the basic timer block diagram. So this is very important. This is the basic operation that I am going to explain. So here you can see the timer clock is derived from RCC. Let's take the timer clock here to be 16 megahertz from the RCC. So which is fed to the timer trigger, and from here the control moves over here to a block called prescaler. So this particular prescaler is nothing but a number which will divide the timer clock further, which is derived from the RCC peripheral of the microcontroller. So here let us consider the prescaler that we have loaded to be 16, which is a simple number. So what happens here in this block is, further this particular 16 megahertz which is derived from the RCC peripheral to the timer module will be divided by this particular number provided as the prescaler. So 16 megahertz divided by 16 will provide us 1 megahertz as the frequency of timer after passing through this prescaler. So after that the clock count reaches the counter register. So here is what the timer counting happens. So since the timer clock finally after the prescaler is 1 megahertz, the time period for each tick of the timer is 1 divided by 1 megahertz, which is nothing but 1 microsecond. So here we have an auto reload register. So this auto reload register is nothing but the register useful for loading the pre-programmed value as we discussed before. So let's assume we have loaded the value 5 right over here. So for every 1 microsecond, this counter register will be updated by the value 1, since we have programmed the timer frequency to be 1 megahertz. So once it reaches 5 microsecond, after 5 ticks of the timer, the comparison between these two, that is the auto reload register and the counter register, matches. So as soon as this match happens, the timer interrupt will be interrupting the processor if you enable the interrupt, or the particular logic that you have written inside the program of the microcontroller will be executed, and this particular, if you are programming the timer in manual mode, and this particular counter value will be cleared to 0. Again the process starts from 0, and again this particular match happens, and this is the process of timer. So this is what the basic operation of timer looks like. So I hope you understood the basic operation of timer and the varieties of timers available in STM32F4 series microcontroller in this video. See you in the next video. Thanks for watching.